Welcome back. Christine Choirat is going to be our next speaker. She is Chief Innovation Officer at the Swiss Data Science Center. She has a wide career in different research institutions on both sides of the Atlantic. And what is particularly interesting about the presentation is that we are moving towards policy areas, particularly public health and environmental policy. So, Christine, thank you for being with us. We are looking forward to your presentation.
Thank you so much. So I'm delighted to be here. So thank you, Roy. Thank you everyone for attending. So I'd like to present two examples, actually on both sides of the Atlantic, on so potentially big problems and big problems where we have a lot of data. So I'll use two policy takes, one on air pollution epidemiology, so pretty much the impact of what we breathe on our health. And the second one will be on the current pandemic, so COVID-19, and about forecasting what's going to happen very short term. And the moral of these two stories will be focusing on what I call research data platforms. And these are tools that we're developing at the Swiss Data Science Center, where I'm currently working. And if I start with air pollution epidemiology, so it's I spent quite a lot of time on the other side of the Atlantic, so at Harvard with a team who is really studying the effects on health. And so if you have some imagination, you see here on the left-hand side, you see Madrid. On the right-hand side, you can guess that it's the Duomo in Milan. And at the bottom, you see the Eiffel Tower. So that's this smog, which is this yellowish haze that you may have experienced in your life. And it actually comes from so a combination of different pollutants, and in particular, particulate matter. So particulate matter is not about what it contains, it's about the size. So it's very fine dust, right? Very fine particles. And PM10 is of size less than 10 microns. And it's typically dust or pollens. And PM2.5, which is the one we call fine particulate matter, very often comes from the combustion of fossil fuels. So it's very, very fine. So it goes very deep in your lungs, and it's associated with all sorts of health effects. We know we know it for a long time. So pretty much you have so cars or traffic emissions or power plant emissions, farming, and you get a set of chemical reactions. And at the end of the day, you end up with particulate matter and you breathe it. So as I said, we know it's bad. So we know it's bad for your lungs, it's bad for your heart, it's bad for your cognitive capacities. It's also bad, it seems, in the current COVID-19 pandemic. And there's also a documented association between particulate matter and mortality, broadly speaking, so all-cause mortality. And so the pollutants are regulated. So they're regulated in the US, they're regulated in Europe. And so my example is from a US perspective, where the Environmental Protection Agency, so the EPA, they, following the Clean Air Act, which is a very, very important piece of law, which was voted in a bipartisan way with both sides of the political spectrum, they have norms. So they issue norms about ozone, about lead, about particulate matter, and we know whether we are doing a good job or we're not doing a good job. And if you look at what happened in Europe between 1998 and 2015, you see, so just to give you the color codes here, very light is very good. So this is zero particulate matter, and that's great. And the darker you get, the more polluted it is. So when you go to 80, you're in real trouble. So up to 10, 15 is okay-ish, and then it gets really, really complicated. So if you look at this little movie that goes from 98 to 2015, you see that Europe is sort of constant, right? It's sort of bad over Germany, Poland, Milan, and things are pretty much in status quo. If you look at what happened in the US, exactly the same time period and the same color scale, you see that what you had in California, the Midwest, and Texas is slowly going away. So you see an improvement in air quality in the US over the same time period. So it brings us to two policy questions, right? The first one is, it seems that there was a different course of events between Europe and the US, so some regulations, so some policies worked better in the US than in Europe. And the second one, so that we know it's been widely studied, but that's not so much what I'd like to focus about. What I'd like to focus about is that, as I said before, we know there is an association between air pollution and mortality. And our research question was, since the air pollution levels are getting better in the US, is there still an impact on mortality? So if you are at a very low level of contamination, is it still bad for your health, and is it bringing like early deaths? And so that's the question we wanted to address. And to address the question, we worked with claims data. So in the US, people over the age of 65 are enrolled in a program called Medicare. So it's a cohort that we gathered. So we gathered information about all Medicare beneficiaries from 2000 to 2012, and we had so it's about 60 million individuals. But if you combine them, you have 500 million people follow up. So it's a very large data set here. And what we did is we wanted to see, on average, whether there was an association with early mortality depending on the air pollution you were exposed to. If you look at the green dots here, these are air pollution monitors on the ground. So air pollution is not measured everywhere. It's measured by devices. And if you look here, for example, in Texas, you would see that many people in Texas have no monitor nearby. So the first step for us was to reconstruct exposure by using satellite data, deep learning, machine learning, to try to reconstruct what people breathe, like pretty much extrapolating outside of the monitors. And then we published. So we published in a good journal. And so we said, yes, even at low levels, there's still an impact. And then we started receiving, all of us, all the contributors of the paper, we started receiving messages like that. And that's a nice one. So you clouds are dead in the water, deserve your fate, your reputation is going to be destroyed, etc., etc. So that's a really nice one. But we received lots and lots of them. And so the point is that we were saying that even at very low levels of air pollution, it should still be improved, right? Like the situation should still be improved if you wanted to lower even mortality even further. But this is expensive, right? These measures and these policies have a cost, and obviously there are like powers that are so economic powers or lobbies that would say that our science is not legit. And the angle that was used to be really, really critical about our work was the fact that we were using health data, we were building models leveraging this health data and then creating and then sharing our conclusions. And the fact is that we cannot share this health data. But there was a policy trend which started a couple of administrations ago in the US that would prohibit the Environmental Protection Agency from actually using scientific evidence that comes from articles where certain parts of knowledge cannot be shared. So in our case, the health data. So it's sort of a catch-22 type of situation. And so I invite you to read what's happening. Like it's been going on for over a decade. And 2 weeks ago, on January 6th, so you may remember events that happened in DC, but exactly at the same time, the same day, a rule was actually passed by the EPA that is called Strengthening Transparency in Pivotal Science, which is exactly that to try to have policy informed by science, where you make it sort of impossible to share the knowledge that you'd like to share, because here we are sort of stuck in the fact that we cannot reshare health data. So that's my first example, right? That sometimes, to construct a policy, you sort of try to cherry pick the science you want to build your policy upon. And it brings me to actually the research data platforms that I was mentioning at the beginning. So 2 years ago, I moved from Harvard to Switzerland, and I joined the Swiss Data Science Center, which is an initiative between ETH Zürich and EPFL, physically located in both places. We're about 60 people, and we have a mission to accelerate the adoption of data science in academia and in the industry. And to do that, we work with domain experts, with academics, with industry partners, but we also build data platforms. And we have, in particular, 2 platforms I wanted to mention. They're free, they're open source. One is called Renku. So it's our analytics platform for collaborative and reproducible data science. And our second platform is called the Swiss Data Custodian, where we add a layer of privacy protection on top of our data, or collaborative data science sharing platforms. And so we are really focusing on, so people have a research question and they gather data, they collect it, they reuse it, they perform an analysis, and then they share their results to the rest of the world. So what we want to do is focus on this part of the analysis, and to make sure that we instill trust, which reminds me of the talk before, Serenata Giamor, where really like the point was bringing trust back to the table, right? And so my second illustration here is this COVID-19 forecasting platform that we put together using Renku entirely. So so in March, Antoine Flau at the University of Geneva was working to try to forecast, to give very short-term forecast of the status of the epidemic in the selection of countries. So we thought that we could team up and create a platform that would help forecast for all the countries and territories in the world, for cantons in Switzerland, provinces in Canada, right? And so we created this tool where we provide like descriptives and also short-term, like 1 week forecasts about what we think is going to happen. So that's Switzerland. And we also have risk-associated maps of like cantons or states or regions where things are going well or things might not be going so well. And my second example here is that we're trying to build tools where we can trust and share insights from data acquisition to model building to result sharing in a way that we try to be as transparent as possible. And the platforms that we are developing, actually, they are used by the WHO to forecast what's happening with the pandemic in many African countries, and also by BAG in Switzerland, so the Office of Public Health, to try to facilitate data and knowledge sharing. And actually, I have 2 conclusions from my 2 stories. The first one is that we tend to focus maybe a bit too much on raw data. And what might be more important to think about is how we share trusted insights. So that's really about that. How can we have an ecosystem where we where we can open our findings and our science when we may have legal restrictions when it comes to data sharing. And so it would bring us to the entire field of privacy protecting tools and techniques, but here I'm trying to keep things at a high level. And the second aspect is in the current pandemic, what I think most countries in the world have experienced is the fact that we need to focus more on big data preparedness, maybe. So when you think about, a lot of efforts related to data-driven insights in the pandemic were done by individual PIs, so individual faculty, hackers, professors, students, giving their time, giving their knowledge, sharing their expertise to try to build solutions in a hurry. So I'm in a hurry, but doing them well. So in a hurry because like the situation was so dramatic and it's still so complicated, and so. It would be, I think, meaningful to think more in terms of big data preparedness, right? And I'm thinking, like, say, the apps to track like contacts that were created and like major achievements, but really done in many cases pro bono. And that's something I think as societies we need to focus a bit more and on a policy level think about how we can get ready for something that was not so unexpected. And so. I'd like to conclude with an almost quote from Gary King at Harvard University, who says that in many cases, I think policy-wise, we don't care about anybody in particular, but we care about everyone. And so we need to rethink maybe the way we want to create potentially tools and how we can move forward. So I'd like to thank, a big thank to the Renko team and Guillaume Obenzinski at the Swiss Data Science Center, Francesca Dominici at Harvard Biostats, and Gary King at IQSS, and Antoine Flao at the University of Geneva. And I'm happy to take questions.
Thank you very much, Christine, for your presentation. It's great to have also the policy dimension into the debates. And that would be actually the target of my first point. It would be basically which kind of different attitudes do you see towards policy-relevant research in the US and the European context? You have a little bit of an experience on both. Intuitively, we had still the GDPR debates in mind, how there might be more concerns or awareness of the use of personal data in the European context. How do you see it with the experience that you have from working actually in the US?
That's a great question, and what I would say maybe is that when you mention like the GDPR, or I tend to think that we have as societies we may have focused a lot on the tech aspect of things and not so much on the policy itself. So we try to, the US would be the typical we let initiatives start, like companies and startups, and then they grow. And then we think about how we can try to regulate what already exists. And the European approach would be a bit the other way around, where we try to set up a policy before we are actually in the situation of having to apply it. It raises a lot of challenges, actually, like how to comply with, say, the GDPR and comply to HIPAA when it comes to cross-ocean collaborations, and it's also, I think, the way also policies can be revised and informed by science. I think it was really the main difference. Like in the US, it's as I was mentioning with my EPA example, it's highly political in a sense, right? It's probably a bit less on our side of the Atlantic, but and we tend to also forget what's happening in Latin America or in Africa or in Asia, where the situation is also pretty different here.
Thank you very much. We now have some questions. The first one is from Elena. Considering that a possible pandemic was foreseen since a long time, why there was no protocol already put in place to collect the data and to perhaps do what you are referring to at the end of your talk, of why we were not ready, if perhaps the scientific community has, to some extent, highlighted these kind of dangers. Why it is the case that we have not been ready when we had to?
Yes, I wish I had the answer. What I can tell you is that it was known, and that's the problem of public health. So we tend to know that dangers are around, that is going to happen. And if you remember, in 2019, I think Johns Hopkins University has this entire pandemic preparedness exercise where they had a very I think it was a coronavirus actually, where they had this exercise of simulation, and it was clear that there were lags in the response. But we tend to focus, I would say it's an investment that is hard to justify if nothing happens, right? Which is the typical narrative of, see, cases are going down, the lockdown was not useful, right? It's hard to get a cross-country collaboration, put everybody on the same page and get ready. But so hopefully the lesson will be learned, because the technologies here, the infrastructures would be there. It's really like it's not so much for scientists than for politicians, right? And I guess that the current pandemic created awareness that it's crucial. But we still have issues sharing data in Switzerland, in France, in the US, and it came, like, if you think the US situation, it all started with Johns Hopkins University, with people just hacking and finding data, right, to gather data. There's I think we may have mentalized the problem, and now I think we need to. We cannot cry about what we didn't do last year, but we need to move forward and really get ready for what's coming next.
I have a last question by Oleg, who is basically asking, how can we try to bring a healthier viewpoint into policy arguments, which are based on anecdotes and assumptions than more bigger data or data-driven explanations? So basically, I think it relates to what you have been pointing out, at the politicization of some of these discussions. What can we do?
So maybe insist on creating literacy in terms of data literacy, science literacy, risk literacy as societies, and as citizens demand from more governments that they improve openness, right? Like, most governments are setting up data sharing platforms, but we would like probably to have more insight sharing tools where we would see possible futures in terms of, if this policy happens, this is what is likely to happen. If it's not going to happen, and evaluate different counterfactual scenarios in the future. But it would take education, investment, and political will.
Thank you very much, Christine, for your insights, and thank you for joining us for this afternoon. I remind that now we have a coffee break, and we hope to see you at the virtual sessions, and we will be back with more talks in a short while. Thank you very much.